Uh, thank you all for coming. We're going to have now the ICAS von Karman lecture. The ICAS von Karman lecture is associated with the ICAS von Karman Award for International Cooperation in Aeronautics. The way we're going to do it, I'm going to introduce the 4 speakers, and then each one of them is going to come up here and give his talk. I'll ask you to please hold on the questions until the end. At the end, the 4 speakers will be here on stage, and then we will open up for questions and answers, okay? All right, so our first speaker in this afternoon is Axel Krein. Axel is the Executive Director for the Clean Aviation Joint Undertaking. He actually joined the Clean Sky as the Executive Director of the Clean Sky program in February of 2019. And prior to that, Axel has held various positions in Airbus. Actually, I should say senior vice president positions in Airbus, right? And from 2000 all the way to 2019. Axel holds a master's in aerospace engineering from the Tech University of Aachen. Our second speaker will be Dr. Sabine Klauke. Sabine is currently the Chief Technical Officer and a member of the Executive Committee for Airbus since July of 2021. She also has held several positions at Airbus since 2002. She has an engineer degree in mechanical engineering, and I understand those is one of European degrees from 2 countries, from the TU Dresden and from École Nationale Supérieure d'Ingénieurs de Mécanique Énergétique de Valenciennes. I hope I didn't butcher the French, my French friends over here, okay? And she has a PhD also from the TU Dresden. Our next speaker will be Eric Dalbies. He is the Senior Executive Vice President for Strategy, Technology, and Innovation, and also the CTO at the Safran Group. He joined the Safran Group, or what is today the Safran Group, in 1992. He also has held several positions in there, including Executive Vice President for Strategy and Deputy CEO of the Safran Helicopter Engines and CEO of Safran Power Unities. He's also chairman of the Ariane Group since 2017. And our 4th speaker will be Marco Protti. Marco is Vice President of Advanced Research of Leonardo Aircraft Division, and he also is the Sustainability Coordinator. He's a member of the Governing Board of the Clean Aviation Joint Undertaking. He's the Chairman of ACARI Italy. He's member of the Chair Team of ACARI, member of the Board of Directors of CITA. CITA is the Italian Aerospace Research Center. I hope I said it right, Sarah. He is a member of the Technical Committee of the Italian Aerospace Technology Cluster. So, please, Axel, if you could come to the podium.
Yeah, good afternoon. Thank you very much for the invitation, Joao, and thank you for your kind words. The 4 of us, 1 lady and 3 gentlemen you have introduced are representing basically first and foremost the European Commission as the prime partner, but also the nearly 1,000 different entities, research organizations, universities, smaller SMEs, but also the larger industrial companies forming this public-private partnership. And we are very proud of being here today to give you that lecture. And I've understood that if we do a decent job, then there is a chance that we get a medal after the job. So I'm going to introduce the topic matter very briefly only, and then we'll hand over to the lady and the 2 gentlemen. All 3 are members of our governing board. Sabine is the vice chair of the governing board, and the 2 gentlemen are members of the governing board. So you have a high representation of the Clean Sky Joint Undertaking, now called Clean Aviation Joint Undertaking. I'd like to start by showing a slide which has been shown a couple of times already in the course of the last few days, and which is indicating a bit why do we need clean sky, respectively clean aviation. And you see here a tremendous job by the aviation industry, the aeronautical industry, reducing the demand for kerosene per RPK. Here, the red line, significant improvement over time. And you see also the success of the industry, the ASK or the RPK, which has risen significantly over the last decades. I mean, despite all the successes in reducing the kerosene demand due to the increase in passenger demand, we have a fourfold increase in demand and only a twofold decrease in the reduction, which is a topic for many people now, and a topic matter for us to focus exactly on that. So which is definitely indicating that lots has been done, but not enough. So there is more to be done, and that's why there is now the Clean Aviation Program. When you look at Clean Sky, as we are speaking here about Clean Sky 2, we are a European public-private partnership. The one partner, the European Commission, with 50% of the voting rights, and then the private entities with the other 50%. Objectives are clear: 20 to 30% reduction in emissions, being it CO2, being it NOx, and being it noise. The program has been running for some time already, since 2014. The last call was last year, and the final demonstrators are being currently developed, so that we are going to see the final results, the technical results by 23, moving then towards 24, the final timeline of the program. An overall volume of close to 4 billion euros. In terms of project partners on the private side, and you see here the 1,000 entities which I mentioned before, a good balance between industry, SMEs, research organizations and university. And I think that is something we are very proud of. Despite the technological achievements over time, we have created here a unique ecosystem. An ecosystem over the entire European space, but even going beyond, because we also have entities participating from non-European countries. So from altogether, I think 30 countries now who are part of that ecosystem and who have a chance to participate in all those discussions which are being organized in the context of the program. One word about results. You will see in a minute from Sabine, Eric and Marco what the flight and ground demonstrators are all about. But here a view, a more top-down view in terms of what has been achieved. And some of you who are closer connected to the program know that we have something which is called Technology Evaluator. This Technology Evaluator is evaluating the different technology elements being brought together at different concept models. And you see here from long range to commuter, and you see that the 20 to 30% target, which was set at the beginning of the program, is in most of the cases achieved. This evaluation was done about 15 months ago, and you see there are two numbers, specifically two numbers which I don't like, the 13% for long range on the CO2 side and the 8% NOx on the short-medium range side. I think the 8% is something which we definitely can fix because low NOx combustion was not taken into account there. So that's easily to be fixed in the second technology evaluator assessment, which is going to happen as we speak now. So the results will be available towards the end of this year. The 13% for long range are going to be a challenge. We are going to be a bit better with the second assessment, with more technologies included there, but that's going to be remaining a challenge because the baseline is an A350 XWB. Last words on a few major numbers. First, more as a background information, 18.5 million jobs are being supported by the aviation community in Europe. In 2050, today it's roughly 11 million. So that's going to be 18.5 in 2050. I think more importantly, I would like to focus on a bit on the two other numbers, 8.6 billion of economic benefit, which has been calculated now recently in a study which was performed just up to the summer by some external consulting companies which have worked and have found out this impressive number. But even more impressive, the 320 billion of environmental benefits due to the Clean Sky 2 program, 60% on the NOx and 60% on the CO2 and 40% on the NOx side. So impressive numbers in terms of socioeconomic impact. So not just about technology, but also about economic and socioeconomic benefits and environmental benefits. So now I would like to hand over to Sabine. Sabine is going to focus on the large passenger aircraft and airframe and systems area. Please, over to Sabine, the CTO of Airbus and our Vice Chair of the Governing Board.
Good afternoon, and thank you, Axel, for the words of introduction. It is a privilege to be amongst all of you today, and I'm really proud as well to be here as the co-chair of the board of Clean Sky 2 and Clean Aviation in the future. And if I've seen the program of these last 4 days, I'm really impressed. We are just a little, we can say, dot on the I or the cherry on the cake at the very end. But all the more, it's really an honor for me to be here and to be summarizing a couple of the things and a couple of thoughts around what is Clean Sky 2 for us. Because it's as well talking about and the recognition and dedication, or for the dedication of what all the different colleagues have done over the last 8 years. And Axel has shown the frame of the program. So why is Clean Sky 2 important to me? We as an industry, we are all committed to do this net zero for aviation by 2050. It is a huge transition. And if we are on that path, and on that path already for 8 years now with Clean Sky 2, that is due to such programs. So Clean Sky 2 is for me a major contributor to that, and all the more we need to be even more disruptive in the future, and that's actually what is as well one of the mottos of Clean Aviation in the future. And secondly, if Clean Sky 2 is kind of prepared to be rewarded, I understand it's also because of this ecosystem, because of having been able to build such a successful cooperation between industry, research partners, small and medium enterprises and the university. And this is for me so important, and this is what transpires in an event like this one as well. So Clean Sky 2 has really permitted to learn about a lot of different technology pathways, demonstrate disruptive aircraft configuration, distributed propulsion, more electric aircraft, laminar flow technologies, next generation integration of fuselages and different materials. So there is just a few to mention. And Airbus, as one of the partners, is really humbled to be part of the program alongside with so many very wise people and R&D partners. So I think we can be proud of the progress that we have made together, and as well in the way we have created this ecosystem together. So if we look at what is the contributions, Axel has given the summary. I think it is really a remarkable approach to be able to build this public-private partnerships, because this is the only way in front of the size of the challenge to really bring the things forward. So, and as we are engineers, and it's always easier to be inspired by concrete things, I really would like to give you a couple of examples rather than generalities. So they're all from the large passenger aircraft, which is the biggest Clean Sky 2 program, and which is 3 different platforms, which is gathering, I think, over 23 demonstrators in the overall program, 29 core partners, over 13 countries, and we've seen the overall results in Axel's summary. So let me just highlight a couple of examples. And you see photos of all of these. So the multifunctional fuselage demonstrators, it's one of the flagships, and it's an 8-meter demonstrator of thermoplastic fuselage barrel, where for the first time we also used ultrasonic welding to fix the different parts and to integrate the parts. So this is actually really focusing on high production rates in order to do composite fuselage structures. The weight reduction, if we look at a fuselage, will be around 1 ton. And as well, and that's not always going alongside, it would be for the reduction of recurring costs and hence with the weight as well the CO2 emissions. So here the production of the first major parts has been done as well as the integration, and it's really showing the thermoplastic capabilities and how we innovatively can assemble. And of course, this has always been done with various partners, and I will not name any of them in all the presentation because I'm not speaking for Airbus here. The second one you can see on the left side is the scaled flight demonstrator. It's a flying aircraft model, which is kind of the 1/8 of the size of a single aisle. So it has already done its maiden flight in March this year. And the importance of it is actually to validate the models and actually make sure that we can do scaled flight tests, which will actually help overall in much easier tools to flight test disruptive configurations. So we've heard just before about a couple of the very disruptive ones. If we have a validated model in order to do it with smaller aircraft, it will really help de-risking full-scale aircraft behavior tests. And the third one on this page is actually about a hybrid electric propulsion ground test bench, which is the result of a successful integration of, on one hand, a megawatt generator, and on the other hand, power electronics into a full test bench. So this is a major basis as well in order to go on with high power electrical tests and to prepare for future architectures. So here it is to demonstrate a hybrid electric propulsion system, which is going up to 2.5 megawatts, which is a big range, and I think the first time that we have integrated such a big electrical ground test installation. And of course it's coming as well with the simulation and functional integration testing, which is going along. If we just take a couple of other ones in a different scheme, so there is the distributed propulsion flight test demonstrator, which is here again on the left side, which is really de-risking in a first place already electric propulsion and distributed electric propulsion technology. And here it's in the wind tunnel, but also for the flight controls in the wind tunnel tests. So this is the basis again, and if we look at not only at the past and the successes, but also in the outlook for the future, it is always laying the basis in order to go forward and into going to the really disruptive things which we will have to do for the future if we want to reach net zero. So another one shows an actuator. Why the actuator? Because it's actually standing for what we call the Smart Integrated Wing Demonstrator, which is here again looking at different flight control systems and going along into the trends of more electrical and full electrical aircraft trends. So here it's really tackling as well all the different and all the difficult situations during a mission, high precision in and high loads, redundancy, everything you need for a full architecture. And that has been integrated into this smart integrated wing demonstrators. And the last demonstrator, which you find here on the page, is bringing us into the disco. Unfortunately, this time not for dancing, but even for much more impressive things. Because DISCO stands for the Disruptive Cockpit Demonstrator. And this is one which is specifically to my heart because it is really integrating a lot of disruptive technologies, preparing the way to actually bring help and safety to the pilot in the aircraft. And this is as well part of a roadmap which is of course bringing for the first time a lot of artificial intelligence and as well really help, software-based help in different modules to the pilots in order to master the difficult situations which he can face during the flight. So it's a major contributor for me to reduce crew workload, to improve the situational awareness, but at all in general then for flight safety as a whole. So it's freeing up the pilot's focus to really focus on the tasks where he needs human judgment, where he needs his full and her full experience, and then to really be sure that we can master difficult situations. So if you've looked at these examples, then it is really just a few of them. And I've seen in the program as well how many presentations you had of the different projects of Clean Sky. And this is for me key because it's paving the way as well to the follow-on, to clean aviation. And here, again, it is for me one of the big levers in order to prepare our way into the transition towards net zero in aviation, sustainable aviation. And this is why I was also directly ready to go into this co-chair role, because it's actually the lever to bring the ecosystem together and really make things happen. So thank you for participating, and thank you as well specifically for all the colleagues in the room who are part of this endeavor for their dedication. By this, I hand over to Eric, who was actually tackling the next part.
Thank you, Sabine. Good afternoon. In the name of the community of propulsion and engine makers or equipment makers for this sector, it's really my pleasure and an honor to speak. And I should add that it's always a pleasure also to speak after Sabine, because the big picture is always well presented when you speak after Sabine. So it's easier for me also to dig rapidly into some of the examples I would like to introduce, so that you can have more intimacy with the level of achievements that have been made already through the Clean Sky 2, and that we, with Axel, anticipate to pursue through the Clean Aviation program for sure. Maybe a few introductory word anyway for some of what can be seen sometimes or felt as peculiarities of this area of propulsion and engine. Why? Because propulsion for us is really at the crossroads of technological bricks that you have to mature and improve, but also competencies for module and system integration for the propulsive system and so on. And if you just stop there, it will never ever fly. you have also to have some intelligence about installation on aircraft, be they regional, large commercial aircraft, rotorcraft. And this means that this calls at least for working in the appropriate manner with aircraft makers, with OEMs and so on. And that's part of my pleasure also to be in this sector. And on top of that, when we are talking about technological bricks, especially in the propulsion fields, this also calls for intimacy with the scientific knowledge on the one hand side, and also methods and tools. So that's really, I would say, the winning cocktail that we have to organize. So let's try to share with you some examples and come back maybe to my introductory words as a conclusions. So here, once again, speaking in the name of the community, I would like to pinpoint six examples that are really achievements realized during the Clean Sky 2 journey. The very first one, and that's the picture on the right-hand side, is the so-called ultra-high propulsive efficiency engine. So that's really the pathfinder for the disruptive open fan architecture, now known as the RISE demonstrator, for instance, but it's making really the most of the counter-rotative open rotor that was initiated through Clean Sky 1 and pursued with the Clean Sky 2 test. Actually, the picture here is the counter-rotative open rotor on the test facility that a few years ago. And this is really paving the way for the final architecture of the future engine families that will bring the disruption in performance that were referred to by Axel in his introductory speech. On the left-hand side, you find the Tech TP. More or less, the deal is the same. How to break the barrier of state-of-the-art in the turboprop products with once again a bunch of collaboration and partners inside this kind of project. The point was to leverage inside the Clean Sky program an existing state-of-the-art turbo shaft for helicopter engines and create the step change improvements for a turboprop version of it, breaking down the barrier of the specific fuel burn, introducing hybrid electric as well, introducing also innovation in terms of controls and commands for the single throttle, for instance, to master at the same time the regime and the fan pitch and so on. This was tested in 2019, and this was also a very interesting demonstration of the ability of the European community to cooperate. And from a business standpoint, I would dare to say that it has also demonstrated a capability to challenge the current US-Canadian monopoly in this field. Let's hope that one day this will come to reality with products on the market. The last one on the right-hand side is maybe more illustrative of what I refer to as the need to have intimacy with the scientific knowledge and methods and tools to implement the step changes in technologies. Namely, the Sapphire program was not a program and a demonstrator for a product. It was more oriented toward what has to be done on a dedicated test ring to improve the methods and tools in terms of installation effects of engines on board an aircraft, especially as far as the acoustics is concerned. And so it's still ongoing with the assembly to be finalized next year and the test at the end of next year. And it's very promising in terms of really understanding on this installation effect. And if you don't consider this installation effect on board an aircraft, you may have the better engine configuration worked out. It may lose all the competitive advantage through installation losses and so on. So that's really something that is extremely important. The three other examples, pursuing on the engine side as well, are also quite illustrative of what can be done in the various fields of what we are investigating through a program like Clean Sky and Clean Aviation further on. The maestro on the right-hand side is once again in the field of the turboprops, the innovation in terms of compressor modules, combustion chamber with specific tests performed during the program on this, and the research on the performance of exhausts, for instance, for the sake of efficiency. And all this for sure resonates with the need to decrease dramatically the emissions of this kind of products. On the left-hand side, we have the so-called Invigo project. Once again, it's oriented toward maturing the methods and tools, the methodology, the science around the ground vortex effects affecting the installation of a propulsion system on a wing or elsewhere, depending on where you install it on the aircraft. This was investigated through a scientific approach with here a ducted fan inlet, but it's easy to adapt to an open rotor configuration as well. And I think that the interesting benefit is that, for me, the output of this effort is the calibration of a simulation software. That's really so. That also relates to the method and tools I was referring to. And at the bottom right, you have an exploded view of the ultrafan concept. So once again, trying to find another architecture to investigate and push up to the potential limits to reduce the specific fuel burn. So it's a geared turbofan architecture with a very high bypass ratio. This was initiated inside Clean Sky 2. And this is currently under assembly integration for tests to be scheduled maybe outside the Clean Sky initiative, but this year. So this comes to reality as well. So referring back to my introductory word, what is fascinating, I think, when we look at these kind of examples is first that if I look at the number of partners that were part of the game on each and any of the 6 examples I said. For the UHPA, more than 30 partners. For the TechTP, it's 26. For the others, it's the same order of magnitude. And when we look at what kind of partners we have inside this kind of project, that's exactly the kind of distribution, Axel, you displayed before. It's a blend of large industrial group, driving project where we embark SMEs, we embark research and technology offices, we embark startups, and this kind of communities. So that's really a quite fascinating way to make it in a different manner as compared to what we did in the past. And I think that's also quite illustrative, I think, of at least in the propulsion field, of the Clean Sky, Clean Aviation as a framework today to improve all these capabilities in at the same time a disruptive and collaborative manner between the major players. And that's not so easy, I think. Why? Because it's quite easy, you know, to consider that when you are talking about fundamental science, we organize cooperation, collaboration. The scientific basement, I think, of all this is when we are in this field, we are not in the competitive world. As long as you enter the research and technology, especially the technology field, you enter the pre-competitive or competitive world. And here, the clean aviation, clean sky, and then clean aviation journey consists in having the challenge of organizing and creating a framework for the collaboration, whereas we are talking clearly about technology bricks and research and technology, where usually it's not that easy because competitive aspects enter the scene. And that's, I think, the magics of it. At least that's what we experience in the field of engines and propulsion. So let's take the challenge to make it alive for the clean aviation next session. Thank you very much. And that's my pleasure also to introduce Marco Protti that will illustrate the field of regional and rotorcraft to resonate with what Sabine and myself probably said. Thank you.
Good afternoon. I can see nothing more or less because there is a huge light in my head, but I assume that you are there somewhere. First of all, I was very, very honored to be here to represent a large community of stakeholders that take part to this journey in Clean Sky and Clean Sky 2, and that has worked really hard in the regional rotorcraft framework. They have developed a set of technology and matured and demonstrated several solutions that will really be bricks and cornerstone of future mobility solution. The regional and the rotorcraft does not provide long-range mobility solution, but they really allow to connect a lot of different communities that could not have access easily to long-range travel, that need to have an air transportation to prevent to be isolated, to give them opportunity. And this kind of endeavor that our stakeholders in these two big areas of research have carried out is really amazing. Amazing because in a time frame that is more or less since 2014, they have taken the responsibility to de-risk a quite really wide range of technology that more or less affects all the different components that are inside a fixed and rotary wing solution. And on top of that, they have designed, manufactured, and now are ready to flight demonstrator. And each of us know how complex, how challenging it is to put in flight an innovative solution in a framework in which each stakeholder gives his own specific contribution from university, from research center, from SME. Each of our partners have developed a piece of hardware, a piece of software that has been integrated inside ground demonstration and now are ready to fly. This is really amazing considering the number of stakeholders involved. As I said before this morning, more than 900 different stakeholders have contributed, and more or less half of them belonged to the regional rotorcraft. And you see now 3 pictures in this slide that give you a feeling how ambitious are our rotorcraft community in developing two completely disruptive design in order to test a set of new technology that affect more or less the full system. They talk the airframe, they talk the propulsion, they talk the engine, they talk more or less everything. And on top of that, they have made the effort to integrate all these innovative solutions in hardware that now is going to fly in the next few months. This in itself is more or less a continuous demonstration of the ability of the European industrial base, supported by all the scientific community, to be at the head of this class of solution. On top of that, you see the picture of one of the different configurations that has been developed in the regional. In this area, of course, we have looked to 2 different classes of development. One more focused to improve the more or less conventional architecture of product, in which we worked across different solutions, moving from optimization of the structural architecture to the solution to have a more electric approach in the system of the aircraft, down to the innovative wing design and associated system. All of that with the aim to make more efficient such kind of aircraft that have quite a different class of application compared to the large commercial aircraft that is really the cornerstone of our air mobility. They need to compromise very high efficiency in terms of total ownership cost, otherwise the market will not uptake the solution. But at the same time, we have the responsibility to deliver high level of safety from one side, but also to improve the fly experience on top of this class of aircraft. This is one of the areas in which the regional aircraft has the big challenge on top of that, and we are working on that. But of course, you see that all these three solutions need in any case to comply with the basis of the clean sky and in the future of clean aviation. That is the environmental footprint. We need to comply with very challenging target in terms of reduction of CO2, reduction of NOx, and noise. And the compromise and the trade-off that all our stakeholders have done in order to identify the best compromise in order to have effective solution in terms of comply with the objective of reduction of environmental footprint, but on the other side, to deliver a solution that still are competitive on the market, still does not compromise the safety, and at the end will not compromise, and in reality they will improve the quality of the passenger experience. All that is a part of a journey that is likely not finished inside the Clean Sky 2, but of course the goal is to de-risk all this technology, all this solution at the level that is ready for the next phase of development. Now, some further example linked to the fixed wing. In terms of regional, I can say that there is been an effort ongoing to complete the activity on 2 flight test bed demonstrators. This is a huge challenge for our community. Consider that each of you know what has been the impact on the aircraft community for the COVID, and this has been affecting also the research community. All of us has made his own compromise in order to be safe from one side, but not to stop the research activity. This has been done also in our community, and now we are more or less in the middle of our challenge. One of the 2 flight test beds has been already flight. The second one will fly next year. And each of them will take on board a different piece of innovation that will be ready to be considered for a transition on the product. This is a big achievement in terms of improvement of the fly experience, in terms of comfort for the passengers, in terms of efficiency with the important development in the more electric aircraft, and in terms of structural efficiency of the airframe. The second example on the left is about the small aircraft. This is a very specific class of application that can have in the future a huge opportunity depending on the evolution of the air mobility network that is now under discussion. The capability to realize in Europe aircraft that comply with the tight safety requirement on one side, but will be more efficient and with the competitiveness that put them in a fair competition with the surface transportation, at least in some specific area, it's one of the goals that this community has perceived. The results are really amazing, considering the class of business associated to this. And we are confident that also in this area there is a huge opportunity in the future. The last point that I mentioned already is relative to the passenger experience. There is several demonstrators that has been developed in order to reduce the noise in the cabin, the vibration, and to create an environment also in a relative small aircraft that I cannot say is similar, but is competitive with the one that we have in the larger aircraft. You know better than me what is the difference flying on the A350 or on the ITR 42 or in the small commuter. We need to develop solution in which these three experiences try to be similar, in which the passenger, that means ourselves, sometimes in our life, will use, depending on the specific need, one or the other class of air transportation with the same confidence, with the same attitude, because we have a good experience and we have a good compromise in terms of cost and efficiency of the use of this kind of transportation. Said that, I want to look even further to the specific technology achievement. I want to say that in this specific area, one important achievement that has been pursued is also the contamination of this class of system with the technology coming from the more large aircraft, because the communities, the scientific community, the research center have the possibility to explore how some solution that seems sensible for large aircraft can become also accessible for smaller aircraft, fixed or rotary. This is not straightforward. If we have an actuator that is fine for a A350, it's much more challenging to integrate it in the wing of a ITR because of course the sizing is not in itself a requirement, because all the mechanics, all the solutions that are behind is in itself. So this for me is one of the most important things in which few opportunities exist other than clean sky, in which the full scientific community can look in a holistic way across different class of application and use it in the effective way for different class of product. I think it's enough for myself. Thank you. I would ask now Axel to come on stage.
Yeah, thank you very much, Marco, Eric, and Sabine, for providing an overview about the technical content of the program. You must know we have more than 100 major demonstrators, and that was just a glimpse into the portfolio of different demonstrators. And I think sometimes it could be a challenge for a person coming from a company A, representing a demonstrator being led by a company B, potentially a competitor. But in this case, the three of them have been speaking on behalf of the 1,000 entities represented in the program, and I think it gave a good overview in terms of technical content, but also in terms of how we work together, how the technology is being developed in a cooperative way among the different partners. The session is about Clean Sky 2, but nowadays I think we can't be on stage somewhere without speaking about Clean Aviation. Clean Aviation is the new program. Clean Aviation is the program where the first call is currently out for evaluation. So the Clean Aviation program, the first call, has an overall work volume of 1.8 billion euros. So a significant volume which has been put out there, and currently we are in the final stages of the evaluation. So the entities, being at universities, SMEs, research organizations, and bigger industrial companies are expecting our feedback by next week. So we are in a very decisive phase of that program. But I would like to use this opportunity to briefly outline a few elements of it so that you are aware about what's going on there in clean aviation and what are the major drivers and what is the major focus area. I think this just as an introduction in terms of understanding where we are going to focus on. I think it shows very well that the overall ambition is climate neutrality by 2050. And what we have been doing, and as the stakeholdership in the aeronautical world, we have been looking at the different contributors to achieving that goal. And you see here two colors, the blue one and the green one, which are significantly contributing to that goal. About 1/3 coming from technology and about 50%, good 50% coming from alternative fuels. And those are the two areas we are going to focus on in clean aviation. Obviously the upper part, the blue part in terms of technology, but also the lower part, not so much on the sustainable aviation fuel area, which is linked to, for example, power to liquid, more in the field of hydrogen. And I come to that in a second. Overall, the program is again a public-private partnership. The European Commission as the public partner, and then the SMEs, industry, research organization, and the universities as the private side, altogether an investment of more than 4 billion euros. The timing is now, the technical work is going to start towards the end of the year. The last call is going to be in 27, and then we are wrapping up towards 2031, in line for the entry into service, which is planned for the products which are behind there, for the subsequent development work, which will start in 28, 29, 2030, in order for an EAS around by 2035. And you see here the current membership, again, European Commission prominently there, and then the private side, somehow the who is who of the European aviation eco context, but you see as well entities there, and specifically, and I've been asked in the course of this conference a couple of times whether we are also open for non-European entities, and you see here, for example, companies like Honeywell Collins, etc., with us obviously being headquartered in the US, but we are open to support also financially all the entities in Europe which have an engineering and a manufacturing base in Europe. So it doesn't need to be, and what is not allowed to fund a commercial office somewhere. So we are focusing on engineering and manufacturing resources in Europe. But in terms of contribution, we can't fund entities in other parts of the world, but those entities are invited to contribute and then have either the self-funding in place or being funded by local governments somewhere else. So that's the ecosystem we are working currently with. There is another call for expression of interest going to happen in 2023. So we are asking for more members to join that club. But, and I think that's very important in terms of contribution to the program, technical contribution, participating in the calls, you don't need to be a member. So the members are there to help us defining the strategic direction, the orientation, but in terms of contributing and participating in calls, it's open for everyone. So you don't need to be a member to be in. And those are the three thrusts we have been talking about a lot over the last couple of days already. First and foremost, the hybrid electric one, then what we called ultra efficiency aircraft concepts and propulsion architectures for short medium range. And then the hydrogen in the middle, focusing on both applications, either in the regional aircraft field or in the short medium range aircraft field. And we are targeting the technology readiness level 6 by 2028, 29, 2030, in order to be on time to allow the industrial community then, with all the supply chain involved, to present those products to the market by 2035, so that those products can be certified and enter the commercial market by 2035. In terms of content, in terms of focus, we are speaking about skipper generation. So we are not targeting the typical 10, 12, 15% improvement. We are targeting 30% improvement for short medium range and 50% improvement for regional aircraft. And that's why we are going to look at pushing the envelope in the traditional aeronautical sectors, aerodynamic structure systems, propulsion obviously, but also some so-called non-traditional sciences. When we speak about hydrogen, definitely non-traditional for aviation. When you speak about thermal management, electricity, all those are topic matters, high voltage, all topic matters which are normally not in the standard traditional aeronautical disciplines. Those are the focus areas. And we also need to make sure that the manufacturing comes not too short there, because we would like, and we have in mind, that 75% of the global fleet by 2050 will be flying with those technologies on board. So there is a huge impact as well on the manufacturing and on the entry into service and on the operations. That's why simulation, digital twin, and innovative certification methodologies are an important element in the program. And that's why we are also including EASA, the European Certification Authority, directly from the onset into the program. So they are working with us in order to make sure that the white sheet of papers which do exist in certain areas will be filled over time together. My last slide, giving those of you who are, maybe there's one or two in the room who are not engineers or scientists, giving you an insight in terms of the return on invest, because we're also always speaking about technologies. We are speaking about the investment for research and innovation, and we have quantified it here with roughly 12 billion euros for Europe. So 12 billion euros need to be spent in Europe by the Clean Aviation Partnership, but as well by regional opportunities, by country opportunities in the different member states, but also by private investments being carried directly by the private entities. So a 12 billion requirement, which then subsequently leads to 50 billion product development, because we have assumed that 3 aircraft programs will need to be developed afterwards, funded then by the industrial supply chain. And finally, 5,000 billion euros need to be spent by the airline industry to buy those new products. So it's something where you initiate an investment in terms of research, and where finally much more money is being generated, and much more money needs to be generated in order to finally come to the product development and finally the implementation into products in order to bring the benefit to the market. And that's, I think, how I would like to end the presentation here. The Clean Aviation Program is very much focused on impact. So we are being measured by impact, although we are not going to see the impact directly, because we are going to finalize our work by 2030. Thanks a lot, and now back to João. Thank you.
I think we can go ahead and invite all the other 3 speakers, if you want to come over here, please. Okay, so it's open for questions.
You stay in the middle.
With pleasure. No questions.
Over here, over here.
Hello, Ramon Lopez from Safran. We've heard about the objective of 75% of the fleet being this kind of newer generation kind of configurations, let's say, with hydrogen or SAF or whatever it is. Is that, let's say, a realistic objective, in the sense that obviously the airlines need to be involved and open to renew the fleet in a way they need to have a kind of an incentive in any way. So is it, let's say, has there been an analysis of the realistic approach of this 75%?
Yes. In short, we have been looking at the current replacement rates. Current replacement rates are roughly 3% a year. And those replacement rates are a little bit higher than the 3%, but we believe there is a huge incentive coming via the cost of CO2. When you look at the cost of CO2, and we are also thinking that there might be a cost of NOx in the future, and by those costs rising, that those aircraft will be absolutely vital in order to continue flying. So it's not just a question of affordability, it's also a question of keeping the airline industry alive. And we do not believe that this is coming just by telling that they need to do it. I think it requires, as you indicated already, incentives. And that is also something which was coming out of our last socioeconomic study that we are promoting, and we are discussing as well with the political environment in Brussels, for example, that there needs to be incentives, financial incentives as well for the airlines to increase this 3% replacement cycle per year to a slightly higher number in order to make the 75%, in order to really become climate neutral by 2050.
Yes, please, Detlef.
Yeah, Detlef Müller-Wiesner, retired, and I'm in charge at the International Academy for Air and Space for the coordination for sustainable aviation fuels. And we have seen here that hydrogen and sustainable aviation fuels shall play a role for aviation in the future. Who is taking care at the Commission that we have enough green energy and that we will have enough hydrogen in the competitive sectors with automotive and other industry in the future?
Commission is you.
Shall I do again?
Commission
Yeah,
is you.
please jump in at any time. But if the word commission is various answers. I believe it's a question of demand and supply. If there is demand, there will be supply. I'm sure about that. This is one answer to the question. But nevertheless, I believe we need to initiate the supply, and we need to support the supply to happen. And I refer briefly to an initiative which was very recently launched by Commissioner Breton, an initiative to ensure that all the factors which need to be put in place after a successful technology development are being taken care of. It doesn't say that there is a solution already, but this initiative, which is called ASEA, which stands for Aviation Zero Emission Alliance, which is in foundation. I think the first meetings are going to happen in autumn of this year, and they will basically look at everything what happens after the research and development work, including obviously the renewable energy which need to be there in order to produce the hydrogen, because as you know, you need hydrogen either for direct burn or for fuel cell, or as a feedstock for the sustainable aviation fuel production.
But Detlef, I mean, your point is very valid, and of course we have been looking a lot on the technologies for the product itself. Just now, of course, for me, sustainable aviation fuels is one of the big pillars that we need now. We think technology-wise, it's basically ready. We need exactly this market uptake, and here it's a lot about how can we all bring that together with incentives for the right invest in the production means, but also with the targets which are put out. So we need the political and governmental system here as well to play. If I look at what can we do outside the Commission, let's say, as an industry, we are trying to act as a catalyst as well. So we are in a lot of alliances with with energy makers, sustainable aviation fuel makers, airports, in order to explore how we bring the infrastructure into the right level and make sure that this is starting and getting on now. And of course, for our internal flights, logistics flights and so on, we are also using blends now. And then it's not the same supply situation everywhere, but in some of the airports we are at 18% now that we can use.
Yeah, and Axel, you referred to the Aviation Zero Emission Alliance launched by the Commission this year, but in the same time frame, the DG Move has launched another dedicated alliance called the Renewable Low Carbon Fuel Value Chain Alliance, quite long term, specifically devoted to creating the case for the emergence of the scale-up of SAF production at European level at least, and this is especially dedicated to the two major industrial sectors that are not that easy to decarbonize, namely aviation and heavy maritime transportation. Yep. This is now in place since this summer.
Mm-hmm. Okay, I don't see any more hands up. Oh, I'm sorry, please.
You predicted by 2050, 75% of the aircraft would be new technology. What percentage of those aircraft would use 100% SAF? What percentage would use the fuel cells? Would we have liquid hydrogen, both the technology and supporting chain?
Brilliant question, and there is no answer to that. You can imagine we have made, I don't know how many different scenarios, and the percentages are varying very much. And I think it's very much dependent, to be honest, on the success of Clean Sky 2 still running and of the Clean Aviation program. And the success of what we are going to do over the next 6-7 years is very much determining the percentage between the different areas you were just describing. I think there is no easy answer to that. I could give you the most likely scenario we believe in, but this is probably as wrong as any other scenario which is in there. We first need to work and then see what we can do, but our conviction is that we need to push the boundaries in terms of efficiency increase, but also in terms of the potential usage of hydrogen in order to make the climate neutrality by 2050. And then we will determine what the percentage is going to be. So I can't give you a percentage right now.
I can just add that we are at the beginning of a systemic transition, probably of aviation. And if anyone has the answer of what will be in 20 years from now, probably can bet and become the most rich people in the world. At the moment, because we are here to talk about technology development, means that the risk associated to any of the solution that is now on the table is probably high enough to justify this kind of co-investment, private and public. Probably at the end of Clean Aviation, we have a better understanding. This is our ambition.
Susan?
Yes, Susan Ying from Ampere. So first of all, congratulations to receiving this International Collaboration in Aeronautics Award. That's really great, congratulations. And because it's international, I'd like to ask you a question that is really international, namely global. Because climate crisis is actually a global problem. It's not just European or Asia or America. And in particular, there are some problems that really could result from the collaboration. For example, all these new technologies, some of them do not have any requirements that's in the current IASA or FAA certification writings in terms of the rules, new rules, and so on. Very good example is the batteries. For example, the DO311A, that's been debated forever until today. There's not really a harmonized sort of argument about what we should do in terms of the requirements for certifying the big batteries for small airplanes, not the small battery for the big 787, for example. So have you given any thoughts in terms of doing something about harmonizing these international certification requirements and so on for all these new technologies that you have invested so much to develop?
I mean, EASA is completely part of the program. as the European regulator, because of course, if we talk about an ecosystem, then we also need the governments to advance their regulations and targets, but as well the regulators have to be part of it. This is for EASA, and of course in each and any of the programs and projects, if you're looking towards product improvement, product changes, and which lead to certification, we are also very closely working with FAA. Even if this is a European program here, but we also always need to look worldwide, and you're completely right in this.
Because all of us are worldwide players. I mean, commercially speaking, we are not limited. Our market is definitely not Europe, because as you referred to, the problem is worldwide, and we have the chance to be in a global industry. So I take it as a chance anyway, because it's really, we are committed to find the ways and means to make it happen at a global scale and not just limited to a domestic approach or even a macro-regional approach. So that's, and you're right, if we were in a continuous improvement approach, probably the means of compliance would be just derived from the one or just adjusted from the one that are already known. As we are seeking for disruption in concepts and so on, very often calls for disruption in the way to certify. So approved means of compliance have also to be thought about at the same pace as we anticipate to make the disruption in the technology side.
Maybe I guess one last question, please.
Yes, hello. Many people talk about SAF as a short-term and fairly straightforward solution to implement for sustainable aviation compared to alternatives. My question is, can we currently transport SAF at scale under the same regulatory framework that we use for conventional fuels? And if not, then what is the fastest way to get there?
For me, in the logistical framework for SAF, there is no distinct need, because it's exactly then responding to the specification of today known jet fuel. So this is not the limiting factor at all for SAFs today.
Anyway, it depends upon what you consider as SAF.
Yeah.
As long as we are considering SAFs as hydrocarbons produced in another way, Sabine's point of view is perfectly valid. The step is if we embrace hydrogen inside the definition of SAF, and for this, there is a regulatory approach, but more than that, there's a question of industrial logistics to make it happen, and that's also a field to be completely investigated, as well as the capability to scale up the supply worldwide of this hydrogen. Anyway.
Okay, well, let's thank our speakers again. Well, I guess going back to your comment, I think you guys earned the award. Okay, so
It's okay.
okay, right. So seriously, the ICAS von Karman Award for International Cooperation in Aeronautics has the purpose of acknowledging exceptional achievement in international cooperation in the field of aeronautics, being awarded to a project or program in which two or more countries are major participants and which is characterized by substantial technical achievement, scientific or technological advance or benefit to society. So for 2022, ICAS is awarding to the Clean Sky 2 joint undertaking the von Karman Award for International Cooperation in Aeronautics, and the citation reads, Clean Sky 2 is a unique global program which has created a high-performing international cooperation ecosystem for aeronautical technologies for some 5,000 scientists and engineers from 30 countries, extending far beyond the European Union member states, bringing together many of the best minds. Clean Sky 2 drastically accelerated evolution towards sustainable aviation and prepared successfully the follow-up program, Clean Aviation. The Clean Sky joint undertaking has proved to be a unique cooperative frame combining flexibility and steadiness, to deliver tangible outputs. So it is my pleasure.
Then I would suggest.
Oh, yes, please.
We get
I
the
understand
three
there are
other
two
gentlemen
or
because
three
in
more
order to be
gentlemen that-
complete, Michael
Michel?
Kyriakopoulos from the European Commission, Michel Peters representing the research community, and Spiros representing the universities. So then we are complete in terms of representation.
So it is my pleasure then to give to you the ICAS Von Karman Award.
Thank you very much.
And there is also a certificate, so let's see, for the lady then.
Yeah.
Thank you very much
Paperwork.
to Joao, and thank you very much to ICAS. We are very, very proud of achieving that and being among the winners on that list. And I think we are in very good company. I looked at the list, and there is the A380 on that list. There is the B787 on that list. There is the A350 on that list. So I think we are in very good company, and we're very proud. Thanks a lot, and also thanks for organizing this event. I think it's a perfect platform for scientific engineering exchange and for meeting people and talking. Thank you.
Thank you. Well, there's one more thing here. ICAS has created a brand new medallion. So, I mean, you have your hands full. So
I'll give it.
Thank you.
Oops.
Sorry.
and this one you guys don't have to share. It's one for each one, okay?
Thank you.
Thank you so
Okay.
much.
Thank you, Joao.
Yeah. See?
Three.
Hi.
Okay.
Okay.
Yeah.
I think a round of applause is correct. Thank you.
Okay, so photos taken. Thank you. And we need to leave the stage to you, Joao, again.
Okay.
Thank you.
Okay, thank you.
Yes, yes, thank you.
Well done.